Okay, this is chapter 25, current, resistance, and EMF. So there's a few new formulas about current that you need to know. Okay, I'm gonna go question by question and teach them to you. Okay, so for current, the easiest formula is I is equal to Q over T, and if you ever see it, it's the derivative of charge with respect to time. Okay, but the new formula is I is equal to N times E VA. Okay, or you could say NEAV or NAVE, whatever, but it's just these four things multiplied by each other. Okay, what's N? N is number of electrons. E is charge of the electron, which is 1.6 times 10 to the minus 19. You need to know this. A is the area, and V is the current drift velocity, sorry. Okay, so this is what everything is. So over here we have the area is 1.4. We have this many electrons, and they gave us the charge of each electron. They gave it to us here, so they were nice. You don't have to memorize it. And they said that the drift velocity is 1.1. Find the current. So we're going to use this formula: N times E VA. So AI is equal to N, which is 8.2 times 10 to the 27 times the number of electrons, 1.6 times 10 to the negative 19. V is the drift velocity, which is 1.1, but we need to multiply it by 10 to the minus 3 because it's in milli. A is what? 1.4. Again, we need to multiply that by negative 3 squared. Why? Because you're going from millimeter squared to meter squared, so you have to multiply by 10 to the minus 3 squared. Okay, so let's do this. I wrote it already, inshallah. Yeah, so N times the area minus 3 squared is just minus 6. Why? Not like the number minus 3 squared, no, the power minus 3 squared. Since power, so you just multiply, it becomes minus 6. That's why they wrote this here. But if you do it on a calculator, it doesn't matter, man. Okay, and then 1.1 times 10 to minus 3 and 1.6 times 10 to minus 19, you get 2.02. Okay, the current of 3.2 amperes flows through a bulb. How many coulombs of charge? Q in 7.5 hours. This is extremely easy. Q is equal to IT, right? I is equal to Q over T, same thing. So 3.2 times 7.5 times 3600 Y needs to be in seconds. Okay, so you get 8.64 times 10 to the power 4. Very easy. Resistivity. So resistivity depends on every material. Every material has different resistivity. But once you change the temperature, the resistivity kind of changes as well. So P final is equal to P initial, or P0, into 1 plus alpha T minus T initial. Okay, T is the temperature, alpha is the coefficient which is given. So over here, they told us that the resistivity initially is this at 20 degrees. So this is T0. The temperature coefficient is this. They want us at 35 degrees. So this is T. Right? So let's see how we're going to find this. We just use the formula. You need to know this. P initial was 2.3 times minus 7 into 1 plus alpha 0.006 into T minus T naught, so 35 minus 20. You can call this delta T as well, it doesn't matter. So let me just make sure this is correct. So 2.3 times 10 to the minus 7 into 1 plus 0.06 into 35 minus 20. Perfect. And you should get 2.51 times 10 to the minus 7. Perfect. Question 4. Resistance now, not resistivity. So a resistance thermometer, which measures temperature by measuring the change in resistance, is made from silver. The coefficient of resistivity is this. So this is alpha. It has a resistance of 40 degrees at 31 degrees Celsius. When immersed in a vessel containing melting lead, its resistance increases to 85 degrees Celsius. Calculate the melting point. So basically they're asking So when the resistance became 85, how much is the temperature of the surrounding? The same exact formula. Same exact formula. Instead of resistivity, we're now working with resistance. R final is equal to R initial into 1 plus alpha T minus T no. Okay, so you're gonna get R initial 3 point, R final 85 is equal to R initial 31 times 1 plus alpha, which is this, okay, into T minus T node. The initial temperature, the final temperature, we don't know, we're trying to find it. That's what the melting point is, like we're looking for it. The initial temperature is 31 degrees Celsius. Solving this equation, it's very easy to solve it. You can just do it shift solve on your calculator. You're gonna get, this 327 degrees Celsius. Question 5. So the answer should have been for the last one, 327. Question 5. A 20 ohm metal wire is cut into 4 pieces that are then connected side by side to form a new wire, the length of which is 1/4 of the original wire. What's the resistance of this new wire? So what do we know about resistance and the length of wires and whatever? We know R is equal to rho L over A. Now this is an old formula, but I'm reminding you of it now. So what is the resistance of this new wire? So R initial was equal to 20, and this was equal to rho, the length divided by area. Now here, what changed? We don't know what R final is. We know resistivity doesn't change, so it's a constant, right? So resistivity stays the same. L over A. Now L became divided by 4, and A became also divided by 4, because if you're dividing the length by 4, then the area will also be divided by 4. Now, I'm just checking this now, because I looked at what I do if I get this answer, and you won't get the correct answer. So then I looked, and basically the new area, A prime, is actually equal to 4 times the original area. Now this is because, and I didn't understand the question. So originally you have a wire cut into 4 pieces, okay? So this wire, length L, cut into 1, 2, 3, 4. 4 pieces. Now what they did is they didn't connect them again, and they didn't have one wire, now L over 4. No, they took all these 4 pieces and they stacked them on top of each other, like this. So you have all of this. So the length is L over 4, but the area, you now have A. Area doesn't change. When you cut the wire, it's still the same wire. But when you stack them like this, it's now 4A. Okay, so A prime is equal to 4A. So over here, the new area, we're going to call it 4A. So L over 4 over 4A, denominator over denominator, what do? You multiply them. So L over 16A. Okay, so it's going to be resistivity times L over 16A. Now we know already that rho L over A is 20. So it's just going to be 20 divided by 16. So that's going to make it 1.25. So the final one is 1.25. I don't like what they did here. It feels weird. So 1.25, okay? Question 6. A 2.10 volt potential difference is maintained across a 2 meter length of wire, and this is the resistivity, which has a cross-sectional area of this. Find the current in the wire. So they give us the area, they give us the resistivity rho, they give us the length, they give us the area, they give us the voltage. Now they want the current. So أول شيء R is equal to V over I, yeah? So we know R, the only formula that has to do with resistivity is what? Rho L over A. Now how can I relate this to voltage and current? R is equal to V over I. So it becomes V over I is equal to rho L over A. This is how you should think in the exam. So you do this, substitute the values, very easy. You're going to get here V over I, I is equal to V over R. So V over, you get this. Okay, you should get 9.38 amperes. That's what we did now. Question 7. A wire with resistance 6 is lengthened 1.5 times by pulling it through a small hole. Find the resistance of the wire after it's stretched. Now, the ideal way is to just multiply by 1.5, but that's wrong. If you see this in your exam, okay, to make your life easier, just multiply by 1.5 but square. Why is it square? I'll explain now. So over here, when you stretch a wire, the volume is the same. The length obviously becomes 1.5 the original length. What about area? Now, since you're stretching it, obviously the area is going to be a bit smaller. Okay? Now, we know that V is equal to V prime, right? What's V prime? It's equal to the area times length prime. What's V originally? It's equal to area times length, right? Now, we know L prime is 1.5 L. So we have A prime times 1.5 L equals AL. We can cancel L with L. So you're going to get that A prime is actually just A divided by 1.5. Okay, perfect. So now we follow the same steps we did earlier. We know resistance is originally 6. And we know that's equal to rho L over A. Now we know R2, we're trying to find it. And it's equal to rho L prime over A prime. And we found out that L prime is 1.5 L. So rho 1.5 L over A prime, which is A over 1.5. So you're dividing this by this. Now when you have something divided by something again, so something over something, you take it up, right? So it becomes 1.5 squared L over A, and you have the rho on the side. Now, this is R2. Now we know that rho L over A is what? 6. So 6 times 1.5 squared. Okay, so if you see this in your exam, just multiply directly by 1.5 squared. It will be easy. So 13.5. Question 8, our last question. A wire of resistivity 9.42 times 10 to the minus 8 is 15 meters long and has a radius of 2 millimeters. What is its resistance? Very easy. Resistance, they gave you resistivity, they gave you length, and they gave you area. It's rho L over A. So it's going to be 9.42 times 10 to the minus 8 times the length, 15 over A. Now, here's the thing. How do you find the area of a wire? It's a circle. When you cut it, it's a circle. So you have to do pi r squared. Now, here's the thing. They give you the radius. It needs to be in meters. So pi times 2 times 10 to the minus 3 all squared. Okay? Pi times 2 times 10 to the minus 3 all squared. Okay? So you're going to get 9.42 times 10 to the minus 8 times 15 over pi. Oh, what I'll do? Oh, ya Allah. 9.42 times 10 to the minus 8 times 15 over pi times 0.006 squared. You get 0.0125. Oh, how did they get that? And 9.42 times 10 to the minus 8 times 15 over pi times 0.006. Oh, radius all squared. Huh? Okay, how did I get 0.06 as the radius? They said 0.02. What the fuck? I meant 0.02. Sorry. So you get 0.112. How did they get 0.112? Okay, some significant figure here. Maybe if you use pi as 3.14. If you use pi as 3.14, I think you get their answer. Yeah, you get 0.113 if you use pi as 3.14, but don't use pi as pi. Never use pi as 3.14 unless the question tells you. Okay, like this, we're done. Thank you so much for watching, and good luck in your exam.